Boom. All right, so we come now to the culmination. Yeah, go and look that up in the dictionary too. Right, again, vocabulary, again, English, and math session, imagine that. Boom. We come to the culmination of this set of videos on the topic of length of a line segment and the midpoint of a line segment. Alright? Now, there's one thing I wanted to notice about these lines here. Notice that this 15 is the same thing as 12 plus 18 divided by 2, which makes sense if you understand the concept of the average, if you understand the concept of what we refer to in statistics as the arithmetic mean. Sometimes we shorten it and just say the mean. The mean is the same thing as the average. The arithmetic mean is the same thing that we normally refer to as the average. The mean is just the average. Alright? So basically, the distance of the midpoint from the x-axis is equal to half of the distance. Sorry, let me say that. The distance of the midpoint from the x-axis is midway between the distance of this point from the x-axis and the distance of this point from the x-axis. The same argument could be made. Well, yeah. So let me start with the x-axis. The distance of this point from the x-axis is 2. The distance of this point from the x-axis is 10. So halfway between 2 and 10 is 6. Alright? 2 plus 4 is 6. 6 plus 4 is 10. We would have actually counted that out in the last thing there. Alright? And the same thing applies for the distance from the y-axis. The distance of this point from the y-axis is halfway between the distance of this point from the y-axis and the distance of this point from the y-axis. So from here to here is 12, and from here to here is 18. Halfway between 12 and 18 is 15. 12 and 3 is 15. 15 and 3 is 18. We would have measured that and counted it out in the previous video. Another way of saying that is to say that the distance of this point from the x-axis is the average or the mean of the distance of this point from the x-axis and the distance of this point from the x-axis. So in other words, this 15 is the same thing as 18. Sorry, we're talking about the distance from the x-axis. That is the y-coordinate. So it will be 2 plus 10 over 2. And the distance of this point from the y-axis is the average of the distance of this point from the y-axis and the distance of this point from the y-axis, which will be 18 plus 12 over 2. Right? 18 plus 12 over 2, which will be 18 plus 12 is 30 over 2, comma 12 over 2, which will be, coming down here now, the same 15, comma 6. Right? That's what we have here. Same story over here. The distance of this point, we didn't give this one a letter. We have to letterize everything. So let me call this one W now. This will be W. Alright? W 15, 6. Alright? The distance of this point from the x-axis is halfway between the distance of this point from the x-axis and the distance of this point from the x-axis. The distance of this point from x-axis is obviously 0 because it actually lies on the x-axis. And if the distance of this point from the x-axis is 8, then the distance of this point from the x-axis will be half of 8, which is 4. Right? Which would be sorry. Oh, you have to forgive me. That's what's happening when you're tired. I see the right thing, but I call in the wrong point. Let me run that again. The distance of this point from the x-axis is 0. The distance of this point from the x-axis is 6. We count, start from here, and we count 6, and we get to here. So the distance of this point, which is the midpoint, from the x-axis would be half of this distance. Half of this distance is 3. Alright? Which is the same thing as, watch it again, 0 plus 6 over 2. So in other words, the distance of this point from the x-axis is the average or the mean of the distance of this point from the x-axis and the distance of this point from the x-axis, which would be, let me come here now, right? Which would be y-axis now, 0 plus 6 over 2, comma, and we do the same thing in considering the distance from the y-axis. The distance of this point from the y-axis is half of the, is midway between the distance, it's half of the, how am I saying that, bro? It's midway between the distance of this point from the x-axis, the distance of this point from the y-axis, and the distance of this point from the y-axis. So if the distance of this point from the y-axis is 8, because this line is 8, because we move from 0 here, 0, 0 to 8, 0, so this length will also be 8. Then the distance of this point from the y-axis would be, this red line here would be half of this blue line here. And if this blue line is 4, then this blue line is 8, then this red line here would be 4. So in other words, the average of, the distance of this point from the y-axis is the average of the distance of this point from the y-axis and the distance of this point from the y-axis. So in other words, we get now, it will be 0. I have to make sure I get the order correct, alright? I'll fix that just now. So the distance here is 0. Now we start with the point 0 first, right? So in this case it will be 0 plus 8 over 2. In this case it will be 0. 0 plus 8 over 2. In this case, it will be the distance. It really doesn't matter, to be honest. Alright, so I'll leave it as that. It really doesn't matter how we write it because we add it. So this would then be 8 over 2, comma 6 over 2. Alright? And then of course that will end up with 4, comma 3. Alright? Right. So basically the coordinates of the midpoint would be the average of the coordinates of the two extreme points at the end of each line segment, at the end of the line segment. Alright? So the x coordinate of the midpoint is the average of the two x coordinates of the extreme points of the line segment, and the y coordinate of the midpoint is the average of the y coordinates of the two extreme points of the line segment. So I apologize for the messiness of the board, but sometimes in maths that happens. You draw what you draw, you write what you write, and it is not always feasible to erase. Alright? But if you're following what we're saying, you would understand at every step of the way, and then you now would be able to make your annotations as you're going along. You would be able to write it in a way and understand it in a way that makes sense to you. I try to make it a little interesting by using different colors so that it will be a little more, it wouldn't be as boring. Now imagine if you had all that in black or blue. I mean, you know, that would be boring. So we mix up the colors a little bit, jazz it up a little bit to make it nice. So now what I'm going to do is rub off all of this and go totally general now to develop the general formula for the length of our line segment and the midpoint of our line segment. So let me rub off the board. Alright. We're leaving all of this in the edited portion of the video too, because this is what would generally happen in a real classroom. Alright. People have to rub off the board and all kind of thing. Rubbing off the board is part of life when any kind of teaching taking place where you have to demonstrate something on a board, right? Whether it's a blackboard or a whiteboard. Now, of course, in times past, for the younger folks in your parent generation, this would be a whiteboard using chalk. And of course, the older students among us, the adults, the mature students, you would also have vivid recollections of the whiteboard, the blackboard, sorry. Now the thing changed up. Using whiteboard now. So, I'm going to go the extra distance of using my little ruler here to make sure that the line segment is straight. So let me say we have a line segment. Boom. A general line segment. And let me say we have another line segment here. Boom again. Right? Now, for the sake of argument, let me just extend the length a little. Nah, the length don't really matter, right? What I'm going to do is actually divide the board in half. So I'll treat with each concept on different halves of the board. Just give me 1 minute. Let me check my time on this thing here. 12 minutes. All right, we have some time still. All right. So, yeah, I'll always share all of what I had to go through to make these videos, alright? The other camera that I'm using there to get the audio signal, I basically would have about 15 to 20 minutes max on that. Of course, when I get a new camcorder and thing, I could have it running as long as I want to have it running. So let us deal first of all with the midpoint, because that is a simpler concept to illustrate. So, let us say we have the point. Now, note very carefully and apply what I'm going to do here in a general sense to everything that we would have done before. Let us say this is the point P, x1, comma, y1, and let us say this is the point Q, x2, comma, y2. Right? Just to demonstrate that you have one point and then you have another point somewhere. So that's all. So x1, y1 is a general point. x2, y2 is a general point. The midpoint of PQ, let me call it M. The coordinates of M, coordinates of the midpoint M is equal to the average of the x coordinates. So the x coordinate of M would be x1 plus x2 over 2, and the y coordinate will be y1 plus y2 over 2. And I'm leaving that just so. And from here, I'm carrying you straight into the exercises. Start with some simple ones. Find the midpoint. Right? And then check the answers and verify that that is in fact the answer. If you want, you could check on YouTube and see how to find the midpoint of a straight line. You'll see the same formula here. The advantage is that I would have just spent maybe a whole hour or more going through a whole lot of stuff, which I hope that you would have gone through, so that by the time you reach here, you get a clearer sense of what this thing is about. Even if you didn't understand every single last detail of all the working that I would have done to get to this point, something in there would have gelled and stuck and you would be able to understand it in a better way than if I just drop that on you and you want to know, well, where that come from, what is about, what's x1, what's y1, what's x2, what's y2. That is what I try to get around by spending all the extra time at the top explaining. Yeah? Right, so that's it for the midpoint. That is all it is. So the coordinates of M would be x1 plus y1, sorry, x1 plus x2. Now, leave that so for now. Right? So that now, having gone through this, in fact, I'll say that at the end. Alright? So, the length of the line segments. Alright? Again, let me use the same P and the Q, just for the sake of argument. Alright? So this is the point P, x1, y1. This is the point Q, x2, y2. Right? Let me use the ruler here just to make the points. Right? You draw your line. This is your line parallel to the x-axis, and this is your line parallel to the y-axis. Those two lines must meet at an angle of 90 degrees. So that's your right angle. So PQ, let me call this the point R. Alright? Now, the length of PR would be x2 minus x1. We kind of went through that as a general example. x2 minus x1. And the length of QR would be y2 minus y1. So whatever the value on the right is, you minus the value on the left. Whatever the value on the right is, you minus the value on the left. No, it doesn't make any difference. It really doesn't make any difference. And I think I would have demonstrated something to this effect in the discussion of gradient. Alright? It doesn't matter which point you use first and which point you use second, as long as you keep the coordinates consistent. Forget everything that I just said there. Just listen and continue. Right? So remember, in the lines that we use, we had the difference between the x coordinates. The important point is to consider the difference between the two x coordinates. The length of the line parallel to the x-axis would be the difference between the two x coordinates, and the length of the line parallel to the y-axis would be the difference between the two y coordinates. I think that is it right there. Right? Difference, that's a very essential concept in mathematics. That is a concept that you'll also use extensively in statistics. Right? And I'm not talking about statistics at CSEC level either. I'm talking about university level statistics, applied maths level statistics in Form 6. So the difference between the two x coordinates and the difference between the two y coordinates, those are the respective lengths of the lines parallel to the x coordinate in this instance, parallel to the x-axis, in this instance, and parallel to the y-axis in this instance. So let me say that again. The difference between the x coordinates is the length of the segment of our triangle here. That is parallel to the x-axis. And the difference between the y coordinates is the length of the segment parallel to the y-axis. Alright? Bim, bam, as we would have had in the previous diagrams. Now, since we have a right angle, then once we establish this situation, it means then that the length of the line segment P that we're trying to find is the hypotenuse of the right angle triangle that we just constructed. And if the length of this is x2 minus x1 and the length is y2 minus y1, then using Pythagoras theorem, we know then that PQ squared is equal to the square, let me get ahead of myself, is equal to, let me write it out in letters first so that you get the thing properly. PQ squared we know is equal to PR squared plus QR squared, right? Which is equal to x2 minus x1 squared plus y2 minus y1 squared. Therefore, PQ is equal to the square root of all of that. The square root of x2 minus x1 squared plus y2 minus y1 squared. And that is the formula for the length of any line segment. Alright? So let me write it out over here again. The length of line segment PQ is equal to the square root. So we say now PQ, the length of PQ is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright? Right. And that is the general formula. So, having gone through all of this, when you get the formula on the formula sheet in our platform here, and I have all the formulas written out here, boom, you're in a better position to know what this means and make sense of it and remember it. And two, boom again, you're in a better position to know what this means, to make sense of it, and to remember it. Now, of course, as always, the next step is to do some questions. Alright? So enjoy the questions, work hard, don't be lazy. Let us get this whole topic of coordinate geometry and straight lines under control. Alright? Boom!